Hello everyone. Welcome to this video tutorial. The purpose of this tutorial is to demonstrate in practice how to build an Apache Kylin-based data analytics platform on the cloud, get high performance, low-cost query experience on top of billions of rows of data, and through MDX for Kylin to manage business metrics, direct interface to BI tools to quickly generate reports. Each step of this tutorial is explained in detail with checkpoints to help newcomers. You only need to prepare your AWS account to follow this video. The process is expected to take about 2 hours and cost about $15 US. In this video presentation, the main parts are as follows. First the background, then the business scenario and step-by-step overview. We will demonstrate how to quickly deploy Kylin clusters on the cloud in a hands-on session. Then connect to the Kylin cluster for data analysis through multiple BI tools. After the data analysis is done, destroy the Kylin cluster and summarize the whole tutorial. Apache Kylin is a multidimensional database based on precomputing and multidimensional models. Support for SQL standard query interface. In Kylin, users can define table relationships by creating models, and define dimensions and measures by creating cubes. Pre-calculate the data to be aggregated by building a cube and save the pre-calculated data. The user can perform further aggregation directly on the pre-computed data, or access the query results directly when executing the query, increasing the performance of the query. With the release of the new Kylin 4.0, Kylin can be deployed in a cloud environment without Hadoop. In January 2022, the Kylin community released Apache Kylin 4.0.1 for more stable deployment and use in production environments. In February 2022, the Kylin community developed the Cloud Deployment Tool, which allows users to deploy a complete Kylin cluster with a single command. For an efficient and fast analysis experience. In March 2022, the Kylin community released the MDX for Kylin, to enhance Kylin as a multidimensional database for business experience. MDX for Kylin provides the MDX query interface for creating business metrics based on Kylin's already defined multidimensional model. Translating data models in Kylin into business-friendly language, giving business value to data. Easier interface to Excel, Tableau, and other BI tools for multidimensional analysis. Based on the above series of technical support, not only can users easily and quickly deploy Kylin clusters on the cloud, but they can also create multidimensional models and experience fast, pre-computed query responses. You can also combine MDX for Kylin with Apache Kylin. By introducing the definition and management of business metrics, we raise the data warehouse technical layer to the business semantic layer. Next, viewers can follow along with this video from the AWS account with a single command to build a data analysis platform on the cloud to connect to BI tools for data analysis and presentation. Let's look at the business scenario that we need to analyze. Since the beginning of 2020, the new coronavirus has been spreading rapidly around the world, affecting people's food, clothing, housing, and transportation, especially the travel habits. This data analysis combines COVID-19 outbreak data and New York taxi travel data since 2018. By analyzing the outbreak metrics and various travel metrics, such as number of confirmed diagnoses, illness and death rates, number of taxi orders, and average travel distance, as well as observing trends in the impact of the outbreak on the New York City taxi industry to support decision-making. We'll do data analysis for the following questions. The first is a joint multi-indicator analysis, the severity of the epidemic in each country and region. The second is a comparison of travel metrics for each block in New York City, such as the number of orders, miles traveled, etc. The third one is whether the epidemic has any significant impact on the number of taxi orders. The fourth one is to analyze the change in travel habits after the epidemic. The fifth one is whether the severity of the epidemic is strongly correlated with the number of taxi trips. This is an diagram of the stable relationship between the two datasets we talked about earlier, the COVID-19 dataset and the New York City taxi dataset. There are two tables in the COVID-19 dataset, a fact table, COVID_19_ activity, and a dimension table, lookup_calendar. In the fact table, the main purpose is to record the number of confirmed diagnoses and deaths reported each day in different regions of the world. Lookup_calendar is mainly a date dimension table that holds extended information about time, such as the beginning of the year, the beginning of the month, etc. for each date. Association between COVID_19_ activity and lookup_calendar by a date field. The NYC taxi orders dataset consists of a fact table taxi_trip_records_view and two-dimension tables New York_zone, lookup_calendar, New York_zone, lookup_calendar, respectively. Each record in the fact table corresponds to a taxi trip record, records the departure location and the arrival location at the travel time, the order amount, the travel distance, etc. New York_zone records the location of the corresponding district and other information. The fact table is passed through the pull location, which is the pickup location of the passenger boarding, the location of the passenger getting off, which is the location drop of location. Create two separate correlations with New York_zone to count information about departure and arrival blocks. The lookup_calendar of another dimension is the same table as the lookup_calendar in the New York epidemic dataset. It is also related to the taxis_trip_records_view by the date field. Here are some details of the two datasets. The COVID-19 dataset contains mainly more than 2 million pieces of data for the period from January 21, 2020 to March 7, 2022. The New York City taxi dataset contains over 200 million pieces of data covering the period from January 1, 2018 to July 31, 2021. Both datasets we have downloaded from the data provider and dumped to our public S3 directory. For the business scenario and the business problem to be analyzed, we designed the following metrics. Mainly atomic metrics and business metrics. Atomic metrics refer to the various metrics that we create in the Kylin cube, and they are often aggregated in a separate column. Business metrics are metrics that are created in MDX for Kylin based on atomic metrics. Business metrics have a specific business meaning and can be used directly for data analysis. In the atomic metrics, we need cumulative statistics on the number of confirmed COVID-19, the number of deaths, and the number of new confirmations in each dimension. Number of new deaths, distance of taxi trips, number of the trips, transaction amount, and trip length. When defining business metrics, we can define them directly to the business problem. In it we define monthly cumulative value of each atomic indicator, annual cumulative value, monthly growth rate, annual growth rate, new coronary pneumonia death rate, average distance traveled by taxi in New York City, average travel speed. After talking about the business scenario, we can start the actual operation of building a data analysis platform on the cloud. Here is the concept of the next steps of our operation. There are 4 main phases. The first phase is the preparation, which is mainly to check and initialize some AWS permissions. Then the deployment tool is used to deploy the Kylin build cluster, to connect to Glue, to build the tables, load the data source, submit the build task, precalculate, destroy the build cluster, keep the metadata. Start query cluster with MDX for Kylin based on the metadata just created to create business metrics. Connect to BI tools to execute queries and perform data analysis. The final stage of data analysis is to demonstrate the data analysis process in the 3 BI tools. After the data analysis is complete, all deployed cluster resources from the deployment tools are destroyed. Here is the architecture of the Kylin cluster, deployed by the deployment tool. The deployment tool allows you to deploy the Kylin build cluster and the query cluster. Both clusters contain 3 Zookeeper nodes, 1 Spark master node and 3 Spark worker nodes, and 1 Kylin node. When deploying the query cluster, we can also turn on the MDX for Kylin switch so that the Kylin node will also have MDX for Kylin installed on it. Used to define business metrics. In addition to some EC2-based compute nodes, the cluster also uses AWS RDS services as metadata storage. AWS Glue acts as a metastory for the data sources and stores the pre-computed data in S3 and provides a monitoring node to monitor the status of the process. As you can see from the cluster architecture diagram, all the resources used except for the EC2 nodes, both RDS S3 and Glue, are persistent. They do not disappear with the deletion of nodes. The data analysis platform is serverless, so you can release the EC2 resources when the build query task is done. Just keep the metadata S3 working directory. When you start a query or build a cluster later, it will remain in the same state as the last time it was destroyed. Here's the hands-on part of our demo. First, 2 preconditions need to be met on the local machine. The first is that you have any version of JIT installed, and the second is that you have Python 3.6.6 or above installed. We can check this from the command line interface. You can see that our current environment meets both requirements. After ensuring that the environment meets the requirements, you can proceed to the next step. The next step is to do some preparation work because the cloud deployment tool needs to create EC2 nodes in AWS. Delete EC2 nodes, upload files to S3, etc. You need to log into your AWS account to check user permissions, and create the access key needed for the deployment tool. IAM role, key pair, and S3 working directory subsequent operations will be performed as the user logs into the AWS account. Now we follow the link provided in the PPT, which is the documentation provided by the Kylin _on_cloud branch on the Apache Kylin repository. The first step is to sign in to your AWS account. We're already signed in. The second step is to add the following permissions to the current user. Let's follow the steps in the documentation. First, you need to create a permission policy in the AWS IAM service. IAM select policy. Select create policy. Go back to the next step. The next step is to select action. Paste the following into the statement. Then proceed to the next step. On this page, we can see that the action file is adding these permissions for services like IAM, RDS, and S3, which we use in our cloud deployment tools. I named this policy Kylin _demo policy. After the policy is created successfully, we need to add the policy to our current user. The current user is found in User. Go to Add Permission to add an existing policy. Kylin _demo policy. This is the policy that we just created. Once added successfully, our user has the privileges we need. The next step is to create the key pair and access key. First, create the key pair in the EC2 service. Find the key pair in the EC2 service. And then quit. Create Kylin _demo pair. After successful creation, the key pair file will be automatically downloaded locally. This file will be needed later when we log into the EC2 node. Then create the access key in the security credential. Inside the security credential, there is Create Access Key. Once created, we can see here, mainly the access key and secret access key can be downloaded from the CSV file. We will use it later when we configure the local environment. The next step is to create an IAM role to provide privileges inside the EC2 node we created. For privilege control, is also created inside the IAM service. This role requires 4 permissions. EC2 role for SSM. Let's check it off. Here is the SSM full access. Two more are S3 full access and Glue Console full access. After adding all four permissions, we can see that the permissions have been added. We can name this role Kylin_demo_role. Click on Create Role. We have created the role successfully. Next, we need to make sure that the current account is with 32 few creation privileges. This is in the EC2 limit. Go to check. The check is running on demand all standard. The current limit can be seen above. This number is at least 32, because the EC2 node we create later. The number of vCPU is to be used as 28. Create an S3 directory as the working directory for the deployment tool. You can use the bucket you already have to create in it. You can also create a new bucket. We'll use the bucket we already have here called Kylin demo to create the directory. You can call Kylin_demo_working. Once the directory is created, we will configure it in the configuration file later. Once the directory is created, you need to initialize the AWS account on the local machine. Here you need to install AWS CLI on your local machine. This is the official tool provided by Amazon. This can be done according to the documentation. Find the corresponding operation in the documentation according to your environment. I have it installed here. Once it's installed, you can use AWS Configure to configure your access key and secret access key. The access key and the secret access key are saved in the CSV file that we just downloaded. I do have the CSV file in the file that I just downloaded. After we open it, we can see that there are two columns in it. The first column is the access key and the second column is the secret access key. When we copy the access key we copy the first column, paste it into the above. I've already configured it, so I won't reconfigure it. Paste in the second column of the secret access key to configure it. The default region name is the default region when the account is looking for resources such as S3 resources or EC2 resources. My region is US East 1. Default format is usually set to JSON. After doing the above, our preparations are complete. After the preparations are complete, we can proceed to the next step. Pull the code for the cloud deployment tool from GitHub. We use one of the commands provided here to pull the code. Wait for the code to finish downloading. Once it's done, we'll open it from within IDEA for easy viewing. Open Kylin 4_on_cloud directory. We can see the deployment tool file directory here. The next step is to initialize the Python virtual environment locally to install some dependencies. The script is provided by the deployment tool, and you can execute it directly. Follow the screen prompts to enter the virtual environment. Next we need to do some configuration of the deployment tool. The configuration file is kylin_configs.yaml. You need to configure something like AWS_region, and the directory we just created for S3 and the key pair, etc. We open the file and we see that the first one is to configure AWS_region, and then create the EC2 node. To access the default region of the S3 directory, we use the AWS account. His default region is AWS East 1. Here is the IAM role we just created called Kylin_demo_role. S3_URI copies the URI of the S3 directory we just created. Here is the name of the key pair we just created called Kylin_demo_pair. The following IP is the whitelisted IP. Only machines from this IP segment can access the EC2 node we created later. This is to block access from unsafe networks for security reasons. For example, if the machine you want to access the EC2 node is at this IP address, then we'll configure it to look like this. Then only machines from this network will be able to access our EC2 node. Once we're done with the configuration, we can deploy the Kylin cluster with a single command using the cloud deployment tool. Following the steps, we first deployed the build cluster, which we do here with a single command. Mainly using the deploy.py file of the deployment script. Deploy type is deploy. Deploy mode is job. Need to wait about 10-15 minutes here. Need to do some S3 file upload and download operations. Need to wait about 10 minutes. The deployment process is quite long. You can skip to 28:51 and continue watching. Okay, now we can see that our cluster is deployed. Once our build cluster is deployed, we can go to the AWS service and look at what AWS services are deployed with the deployment tools. This tool mainly uses the stack inside the CloudFormation service to deploy the set of training. Let's see what stacks are included in the deployment. In this deployment, all the stacks are shown with the prefix EC2. You can see all the stacks that were deployed in this cluster deployment. We can see that there are 7 stacks. This includes the VPC stack, which is used to configure the inbound rules for the EC2 node, and the RDS stack, which is used as a metadata store for Kylin. Static service is used as a monitoring node to monitor cluster status. And some of the services we need for Kylin later Zookeeper, Fark, and Kylin nodes. Let's take a look at the information about the nodes in our cluster using the functionality provided by the Cloud Deployment tool. The list function will list the private IPAs and public IPAs of all the nodes in the cluster so that we can access them. Okay. Here we can see that the private IP and public IP of all the nodes are listed. We can first look at the public IP of the Kylin node. Go to the node area and check if the Kylin web UI is working properly. Login with my admin's default username and password combination. As you can see, the metadata is now empty, and it is working fine. Next, we need to build the table in Spark SQL, and execute the query to see how fast Spark SQL is executing. Before we can build the table, we need to prepare the dataset because our dataset is dumped to our S3 public directory. But it has a region limit. The region for Chinese users is CN North 1 and the region for AWS Global is S East 1. If your S3 directory is also part of 2 regions, Then instead of synchronizing the data and modifying the table build SQL, you can just go ahead and do the table build. If not, if you are a CN user, you need to execute this statement to synchronize the data to your S3 directory. The global user also executes this command to synchronize the data and then uses this command. You can run it directly to modify the DDL. Run the table build SQL after the execution. My S3 directory is located in S-East1, so I don't need to perform the above steps. Just go ahead and execute the DDL. To create the table, we're also going to go to the Kylin node. We log into the EC2 machine through its public IP. When logging in, we also need to use the key pair file we created earlier. The key pair file needs to be given more private permissions like 400. Use SSHI. Use EC2 user at public IP to log in. We are now logged in successfully as EC2 user. Let's switch to the root user and run the source profile command to make the environment variables we prepared in advance take effect. We now go into the Spark home directory. First modify the Spark configuration file. There is a private IP of the Spark master node that needs to be modified here. We can see that the IP list we just made an idea has its private IP on it. Copy it over and save it. Next, we can go ahead and create the table. The table build file is the one we've saved automatically in the Kylin_demo directory of the machine. We can now use Spark SQL to create the table. Okay, now that the table is built, we can go to Spark SQL and query it directly. Testing the speed of Spark SQL querying a billion rows of data. Let's take a look at the configuration file. The configuration file we just opened contains the resource configuration for the driver and executor. This is the same resource configuration as the Kylin query integration that we'll start later. It also says that we'll use the same resources to execute the queries to test their speed. Go inside the Spark SQL. The tables we just created are in the Kylin demo database. If you run use Kylin_demo, you can look at the tables inside. This is the dataset we introduced before. The SQL we defined earlier is to calculate the number of taxi orders, and the sum of the time, and the total amount on top of the time dimension. and the block dimension and to join the new work_zone table. Copy the SQL directly from Now that the SQL has successfully returned the results, we can see that the time spent is about 120 seconds in total. It took about 2 minutes to execute the aggregation and join. We now exit Spark SQL shell. To increase the speed of the query, we need to go ahead and build a cube in Kylin to precompute some data. Let's go to the next step. First, you need to import the metadata of the model and cube into the metadata. Go to Kylin's home and you can see that our data is stored in the meta backup. It is located under the EC2 user directory meta backup. Go to Kylin's home and perform the import of metadata. Now the original data is imported successfully. Let's go to the Kylin interface and reload. You can see that we have the COVID trip project here. There are 2 models and 2 cubes in there. The 2 cubes are the New York trip, the cube for the taxi dataset, and COVID-19, the cube for the outbreak data level. The dimension and measures inside them are created. The dimension and measures inside them are created with those atomic metrics we designed before. The sum of the trip time, the sum of the trip distance, the sum of the new cases, and the sum of the deaths that we've designed. Then we need to build 2 cube. Submit the build task. You can see that both builds have been committed. Now we wait for it to finish building. Now we can see our 2 cube are built successfully. The 2 cube builds took a total of 16.9 minutes. Both cube are now in the ready state. Now our build task is complete. There are no other build tasks. The building cluster can now be destroyed. Destruction command using Python script. Yes, we'll keep the RDS stack VPC stack and the stack of the monitor node. The next time we start the cluster, we'll use the same stacks that we kept before. This ensures that both clusters are using the same original data. Now our cluster has been successfully destroyed. Let's start with the next step.